Welcome back. Today in this session we will be solving numericals on simple stress and strain and also modulus of elasticity. Now let me read the question. The first question says, find a wire 4 mm in diameter, 4 meter long and subjected to an axial pull of 1890 Newton is stretched by 3 mm under the axial pull. Find stress and strain induced. Also find modulus of elasticity. So first let us write down the givens. So from the question given, first a wire is given, its diameter is given. Wire's diameter D is given equal to 4 mm, right? And its length is given. L is given 4 meter long and subjected to axial pull of 1890. So its axial pull P or the force P is given equal to 1890 Newton and is stretched by 3 mm under the axial pull. So this 3 mm here is change in its length. So we can say change in its length, del L is given 3 mm, and next it has asked us to find stress, STRE, stress sigma question mark, and strain E question mark, and modulus of elasticity E. So these are the things that we have to find. So first let us find stress. What is stress? Stress sigma is equals to force by area. This is the formula to find stress. Now we already have force given here. We don't have the area of this wire. So to find area of this wire will be pi by 4d square. Now how much is d? D is the diameter of the wire and the diameter of wire given is 4 mm. So equals to pi by 4 into 4 square. Now how much will we get? Let us do it in a calculator. So I have pi by 4 into 4 square. So I'm getting 12.56. So I'll round it off and make it 12.57. 12.57 mm square. So my area is equal to this much. Now let's find stress. Stress sigma will be equal to force given is 1890 Newton, right? Divided by its area is 12.57 mm square. Now how much will we get? It will be coming equal to 1890 divided by its answer. So it's coming 150.4. It's coming 150.4. Now what will be its unit? The unit of force P was Newton, area and mm square. So we have Newton per mm square. So this is the unit of stress, right? We found stress. Now let us find strain. Strain is signified by E is equal to change in length, right? Change in length by its original length. Now this will be change in length is del L and its original length is L. How much is our del L? Del L is 3 mm here. So we have 3 mm, 3 mm. Now the original length is in meter, so we need to convert this meter into mm. How do we convert this meter into mm? So our length will be equal to 4 into 1000. If we multiply it with 1000, it will be, meter will be converting into mm. So we have 4000 mm. So I have converted its unit, so we can use this one here, divided by 4000 mm. So here mm gets cancelled, and hence strain will not have any unit. Strain is unitless. So let us find its final answer. Final answer will be equal to 3 divided by 4000. Is coming equal to 750 into 10 raised to power minus 6. So instead of writing here, I'll write it down there. It is coming equal to 750 into 10 raised to power minus 6, and it has no unit. Okay, now the last thing that we need to find is modulus of elasticity E, right? So this modulus of elasticity modulus of elasticity E will be equal to stress by strain. So how much did we get? Stress is equals to 150.4 divided by strain is 750 into 10 raised to power minus 6. So let us find 150.4 divided by its answer. So I'm getting 200.5 into 10 raised to power 3. So 200.5 into 10 raised to power 3. And what will be its unit? Since strain is unitless and stress has its unit Newton per mm square, so modulus of elasticity will also have the same unit as its stress, Newton per mm square. So this is your final answer. So we found out modulus of elasticity, strain, and then stress. So these were asked in the question, so we found all of them. So I hope this numerical is clear. Let us move on to the next numerical. Let me read the numerical. A wooden tie, 8 meter, 100 mm wide and 140 mm thick, is subjected to axial pull of 60 kilonewton and elongation is 3 mm. Calculate the value of modulus of elasticity for the material. So here they have directly asked us to find modulus of elasticity for the material. So how do you find this modulus of elasticity? Modulus of elasticity E. E is equal to stress by strain. So we need to find stress and strain, only then we can find its modulus of elasticity of the material. So first let us write down what are given. Given from the questions are wooden tie. So its length is given, L is given 8 meter and its width is given, B is given 100 mm and its thickness T is given 140 mm and is subjected to axial pull, P is given 60 kilonewton. Elongation del L is given 3 mm And now we have to calculate the value of modulus of elasticity for the material. Okay, now wooden tie. It says a wooden tie. So I'm just drawing a rough one. Wooden tie, and its length, let this be the length. It will go up to a certain length, so let this be its length here. L is given 8 meter, and this is its width. B is given 100 mm, and this is its thickness T, or it can also be D. T is given 140 mm. So this is the wooden tie here. Now for this wooden tie we have to find the modulus of elasticity E, right? To find modulus of elasticity, first we need to find stress. So stress sigma will be equal to force by area. Now how much is force? Force given is 60 kilonewton. Now it is given in 60 kilonewton. We need to convert it into Newton. So how will we convert it into Newton? Kilonewton to Newton. It will be 60 into 10 raised to power 3 Newton. So if you multiply it with 10 raised to power 3 or 1000, it will be converting into Newton. Divided by, now area of this tie, this face. Area of this tie, which will be along this face, will be equal to 100 into 140. So this is the area of this tie, and it will be coming equal to let me do it in the calculator. 60 into 10 raised to power 3 into 100 into 150. So this is coming 4.285. So it will be 4.29. So it is coming 4.29, and what will be its unit? Newton per mm square. So we have stress. Now let's find strain. Strain E will be equal to change in length by its original length. So how much is change in length? Change in length, del L is given 3 mm. So we have 3 mm divided by its original length is again given in meter. We need to convert this meter to mm. So converting this meter to mm, it will be 8 into 10 raised to power 3 mm. So this unit will get cancelled and strain will have no unit again. So this will be coming equal to 3 divided by its original length, 10 raised to power 3. So this is coming equal to 375 into 10 raised to power minus 6. 375 into 10 raised to power minus 6. So this is the strain, and it has no unit. Now we have found stress and strain. Now let's find modulus of elasticity for the material. Modulus of elasticity E is equal to stress by strain, and stress is 4.29 divided by strain is 375 into 10 raised to power minus 6. So this will be coming equal to 4.29 divided by strain. So this is coming equal to 11440. 11440. And what will be its unit? Its unit will be equal to the unit of stress, which is Newton per mm square. So this is it again. It is very simple numericals. I hope it is clear again. Let's solve the third numerical. Determine the tensile force on a steel bar of circular cross-section 25 mm diameter if strain is equal to 0.75 into 10 raised to power minus 3. Consider E for steel equals to 200 GPa. Now what is E here? E here is modulus of elasticity for steel. So first let us write down what are given. Given from the question are diameter of the cross section D is given 25 mm dia, right, and strain E is given 0.75 into 10 raised to power minus 3, and strain has no unit. This is strain E, right, and modulus of elasticity E is given equal to 200 GPa. Now what is this GPa? It is gigapascal. Now this gigapascal will be equal to 200 kilonewton per mm square. Now we need to convert this kilonewton to newton. So further converting, it will be equal to 200 into 10 raised to power 3 Newton per mm square. So you get this. Okay. And what have they asked us to find? They have asked us to find tensile force. Tensile force P is what we have to find. Now from this given data we need to find force P. Now first let us find from this relation modulus of elasticity E is equals to stress by strain. From this relation let us first find stress, because if you look at the question, E is given, modulus of elasticity is given, and strain is given. Now from if these two things are given, then we can find stress, right? So how much is E given? E is given equal to 200 into 10 raised to power 3 Newton per mm square it is given. So equal to, stress is not given, we need to find stress. Strain is given equal to 0.75 into 10 raised to power minus 3. Now from here, how do we find? Let us imagine that there is 1 in denominator. So cross multiply them. If you cross multiply them, sigma will be multiplying it with 1. So sigma into 1 equal to 200 into 10 raised to power 3 into 0.75 into 10 raised to power minus 3. So you get this, right? So let us find stress. Stress sigma will be equal to 200 into 10 raised to power 3 into 0.75 into 10 raised to power minus 3. So from here I'm getting stress is equal to 150, and what is the unit of modulus of elasticity here? It is equal to Newton per mm square. So we have stress is equals to 150 Newton per mm square. So we have this one here, right? And this stress so produced here is tensile stress, because what we are finding tensile force. So the force, because of this tensile force, the stress produced will also be tensile stress. Now let us find from the relation stress is equal to force by area. Now we have found stress area we can find from the given diameter. How much is the diameter given? 25 mm. So stress here is 150, right, equal to force. We have to find tensile force P. Area was equal to pi by 4 into diameter given was 25 square, d square, right? So this is my area. Now again, if I cross multiply it, again I'll be getting P equals to 150 into pi by 4 into 25 square. So I'll be getting this. So from here my force will be coming equal to 150 into pi by 4 into 25 square. So I'm getting 73.63 into 10 raised to power 3. 10 raised to power 3, and its unit will be coming equal to Newton. The force will be in Newton. So I'm getting this much. So we have found the force, tensile force. So I hope this numerical is also clear. Let's solve the fourth numerical. A steel rod 25 mm diameter and 2 meter long is subjected to an axial pull of 45 kilonewton. Find stress, strain and elongation. Take E equals to 200 GPa. So here we need to find, let us first write down what is given from the question. So the given from the question are, dia of the steel rod, dia D is given 25 mm, and the length of the rod is given, L is given 2 meter. Subjected to the axial pull, pull P is given 45 kilonewton. Now we have to find stress, strain and elongation, and also modulus of elasticity is given 200 GPa. Again, this, when we convert this 200 GPa to Newton per mm square, it will be 200 into 10 raised to power 3 Newton per mm square, right? So if I convert this 2 meter into mm, it will be 2 into 10 raised to power 3 mm, right? Now let us first find stress. Number 1, stress. Stress is sigma equals to force by area. Now the force given is 45 kilonewton. Now we have to convert this into Newton. 45 into 10 raised to power 3 Newton it will be, right? So we have 45 into 10 raised to power 3, and its area. Diameter is given, so from the diameter we can find area. So area is pi by 4 d square, and d given is 25 square, right? So from here stress will be equal to 45 into 10 raised to power 3 divided by pi by 4 into 25 square. So we have 91.67. So the stress is coming 91.67. What will be its unit? Newton per mm square. So this is my stress. Now let us find strain. Number 2, strain strain E. Now to find strain E, the formula is change in length by its original length. But we do not have change in length here, elongation. This change in length here is elongation, and this in number 3 we are asked to find elongation E here, right? So this elongation E here is del L. Now this is not given here, so how do we find strain? Now we will use the relationship between modulus of elasticity, stress and strain. So the relationship between them is E is equal to stress by strain, right? So from here we will find, since E is also given, sigma we found it from here, and so two terms are given here already, so we can find the third unknown term, which is strain. So from here what do we get? The modulus of elasticity given is 200 GPa, so we have 200 into 10 raised to power 3 equals to, sigma was 91.67 divided by E. Now from here E will be equal to 200 into 10 raised to power 3 into 91.67. So this will be coming equal to into 200 into 10 raised to power 3. So this is coming equal to 18.33 into 10 raised to power 6. So it is 18.33 into 10 raised to power 6, and strain has no units, it is unitless. Now we have found strain also. Now let us find elongation, third one. Elongation del L. So when we covered theory portion in PPT, that time I have covered in last of the PPT how to find del L. So the formula was PL by AE. This is the formula to find del L, right? So P given in the question, how much was P? P is 45 into 10 raised to power 3 Newton into length of the rod is equal to 2 meter, which is 2 into 10 raised to power 3 mm. 2 into 10 raised to power 3 mm. So this is my P, this is my L, by area is pi by 4 into 25 square. So this is my area, into E, which is modulus of elasticity. E is given equal to 200 GPa, which is equal to 200 into 10 raised to power 3 Newton per mm square. So this is my elongation. So let us find 45 into 10 raised to power 3 into 2 into 10 raised to power 3 divided by pi by 4 into 25 square into 200 into 10 raised to power 3. So this is the elongation. So it is coming 0.916. So it is almost equal to 0.92, and the unit of elongation will always be in mm. So 0.92 mm. So this is the elongation. So I hope this numerical is also clear. So let's solve the last numerical for today's session. A load of 6 kN is to be raised with the help of a steel cable. Find the minimum diameter of steel cable if stress is not to exceed 110 Newton per mm square. So now here we are asked to find the diameter of the steel cable if the stress is not to exceed 110 Newton per mm square. So how do we find the diameter of the steel cable? So let us first write down what is given in the question. From the question, load is given, P. Load is given equal to 6 kilonewton. And what is given? Again, minimum, we need to find minimum diameter of steel cable. If stress is not true, stress is given. Sigma is given 110 Newton per mm square, right? So we have to find what we have to find. Minimum diameter of steel cable. So how do we find? So from this much given data, we need to find the minimum diameter of steel cable. So from the relation stress sigma is equals to force by area, we will first find its area. So the stress is given already. Stress is 110 and the force P is given 6 kilonewton. So we will convert this kilonewton into Newton. 6 into 10 raised to power 3 divided by area. Now how much do we get area? So if we cross multiply it, it will be like this, right? So it will be area into 110 equals to 6 into 10 raised to power 3. So from here, area will be equal to 6 into 10 raised to power 3 divided by 110. So this will be coming equal to 6 into 10 raised to power 3 divided by this stress. It's coming equal to 54.54 and its area mm square. So this is the area of the steel cable. Now from this area we need to find the diameter. So area of steel cable A will be equal to pi by 4 d square, right? So from here the area A is equal to 54.54 equal to pi by 4 into d square. Now from here if we again cross multiply, we will get this, right? So from here pi d square will come together, will be equal to 54.54 into 4. Now d square, keeping d square here, 54.54 into 4 divided by pi. Now I want to remove this square, so once I remove the square here, the root will come over here. So the diameter will be coming equal to area into 4 divided by pi. Pi. So the diameter is coming 8.33. So the diameter is coming 8.33 mm. So this is the diameter. If we have to lift this steel cable and the load of that member is 6 kilonewton and the steel cable's stress should not exceed 110. So the steel cable should have its diameter equal to 8.33 mm in order to lift this 6 kilonewton load. I hope this is clear, and this is it for today's session. I hope all the numericals are clear. Please solve all the numericals and see you in next session.